All right, guys, today we're going to talk about z-scores and standard deviations that are not whole numbers. So remember on Friday we talked about standard deviations measuring how far away from the center we are. So when we don't have a labeled standard deviation like we did on Friday, what we're going to have to do is we're going to use z-scores and a calculator. Okay, so what's going to happen is we're going to have to find the z-score using this equation right here. The x represents the value that is given to us. Okay, so value given. Remember, our mu symbol represents our mean, and our sigma, or our circle with a hat, represents standard deviation. Okay, so here's an example. If the mean is 50 and the standard deviation is 4, draw the standard normal curve and then find our z-scores. So remember, mean goes in the middle, and we're going to count by 4s on each side. So we have 54, then we're going to have 58, then we're going to have 62. Going our other way, we're going to have 46, then 42, and then 38. Okay, so remember, they're matching z-scores. This is what we talked about on Friday. This is 3 standard deviations below the mean. This is 2 below, 1 below. The mean itself always has a z-score of 0. Okay, then we are going 1 above, 2 above, and 3 above. Okay, so the z-score for the value of 41, we know is going to be about right here, right? So my z-score should be in between -3 and -2. Okay, but to find it, we're going to use this equation. So we're going to say 41 minus my mu of 50. Okay, then we're going to divide all that by our standard deviation, which is 4. Okay, so when we type that in, it's going to give us, what's that, -9/4, which is equal to -2.25. So about right here, that's where 41 is, and it does make sense that that's the same thing as -2.25. All right, 55 is on this side, about right here. So we know it's going to have a positive z-score because it's above our mean, okay? And we know it should be in between 1 and 2. So my answer is going to be 1 point something, right? So we're going to plug it into our equation just like last time. We're going to take 55, subtract my mean, divided by 4, which is going to be 5/4, which equals to 1.25. So 1.25 is the z-score for the value of 55. Okay, so once we can find our z-scores, we're going to use our calculator to find the probabilities. So before, we used our empirical rule. Remember when we did, it was 68 going 1 and below, 1 and above. Then we said 95% and then 99.7. What we're going to do now is we're going to find percentages like what's higher than 55. Well, we can't just add up percents because we're not including this whole region anymore. So our calculator is going to help me. Okay, so what we're going to have to do, the part of our calculator we're going to use is our VARs button. Okay, so when we find it on our calculator, okay, what we're going to do, I'm going to turn my brightness down a little bit. There we go. Your VARs button is right here. Okay, so we're going to push the second VARs, and it comes up with this menu. Okay, this is our distribution menu, and we're going down to option number 2, which is normal CDF. Okay, and then this is the menu we're going to use. All right, you'll see here my older versions of the calculator, you're not going to have this menu. Okay, it's going to come up with normal CDF and then parentheses, and you're going to have to type everything into it, but it's always the same order. It's always lower bound, then upper down, mean, and standard deviation. Okay. We will never change the mean standard deviation. My mean will always be 0. Standard deviation will always be 1. Okay. But the lower and upper bounds, that's where we're going to have to put in our z-scores. Okay. So the lowest z-score to the highest z-score. And when we do infinities, we're going to use -9 to the 99 for negative infinity. And then we'll use +9 to the 99 for positive infinity. Okay. So let's do one. Let's practice. All right, example 1. So what is the probability of having a z-score that is greater than -2.91? Okay, so again, on my curve, so remember this z-score is 0, this z-score is -1, -2, -3. So -2.91 is going to be about right here. And it wants to know greater than. So we are actually looking at all of this. So we know my percentage is going to be really close to 100. Not exactly, but very close. So our calculator command, our lower boundary, okay, is going to be the z-score of -2.91. Our upper boundary, okay, is going to be going up to infinity all the way over. So we're going to use 9 to the 99. And our mean will always stay 0. Our standard deviation will always be 1. Okay, so when we plug that into our calculator, again, let's go from the beginning. I pushed second, and then vars, went down to normal CDF, enter, all right? My lower bound is -2.91. Our upper boundary is 9 to the 99, and we're going to leave those alone. We're going to paste. So remember, if you have the older model, you're going to have to type it in to make it look like this. And your comma button is actually right here above the 7. Okay, but newer ones, you're not going to have to worry about it. We're going to push enter, and it tells me the probability is 0.9982. Okay, we do always go 4 numbers past. Okay, remember, a probability of 0.9982, that is the same thing as saying 99.82%, which makes sense. This is about 99.82% of my curve. All right, let's do another one. This time, probability of having a z-score less than -1.5. Here's -1, here's -2, so -1.5 is going to be right here in the middle. This time we're less than, so we're looking at all of this. So this time my probability should be a bit smaller. All right, so we're going down to negative infinity. So my lower boundary is -9 to the 99. Upper boundary is -1.5. Keep our mean 0. Keep our standard deviation 1. All right, type it in. Lower boundary this time is -9 to the 99. Our upper boundary is now -1.5. Keep the rest the same. Enter. 0.0668%. Okay. 0.0668 probability, excuse me. So to have a probability of 0.0668, that's the same thing as saying 6.68%. Okay. All right, here's an in-between. So now we're looking for the probability of having a z-score in between -2 and +1.5. So -2 is an actual standard deviation. We like that. 1.5 though, it's going to be right here in the middle. So we're looking at the probability of being in between these two. Okay, so my lower boundary is going to be my -2, right? Our upper boundary is going to be +1.5. Our mean always stays 0. Our standard deviation always stays 1. Okay. So -2, 1.5, keep it all the same. Probability is 0.9104. Okay, so probability, that's the same thing as saying 91.04%. I keep changing these to percents to show you how this answer makes sense with what we're shading in. Okay, this percent of 99% makes sense because I shaded almost everything. 6.6% makes sense. I didn't shade as much. So that's why I keep converting it to percentages so you can see that it does make sense. But we will write our answers in probability form, which has the 4 numbers passed. Okay, so I want you now to try this one by yourself. I want you to pause the video, try it, and then unpause it and see if you got it right. Okay? All right, so you've done your work. It asked you a z-score that is greater than negative 0.91. So here I marked negative 0.91 on my bell curve. I shaded above it, so we know it's going to be more than 50%. Okay, because remember this is half, and then we have a little bit more. Our lower boundary here was the negative 0.91. Our upper boundary was up to infinity, which we're going to use 9 to the 99 to represent that. And our mean standard deviation do not change. We should have gotten a probability of 0.8186, which is the same thing, about 81%. Okay, moving on. All right, so this time I'm not going to give you the z-score. We're going to have to find the z-score, and then we're going to do everything we just did. Okay, so here scores are on a test are normally distributed with a mean of 160 and a standard deviation of 12. Okay, so go ahead, take a second and fill in your bell curve. I'm going to pause the video. You pause it too. Fill in the bell curve and then come back. All right, we've put our mean in the middle. We've counted both directions by 12. I like to put the z-scores below it just so I can keep myself in check. So here I want to know what's the probability that a randomly selected student scored less than 148. Okay, so here we go. 148 is already labeled for me. Okay, we want less than, so we're shading below it. All right, we know the z-score. Okay, the z-score is -1, but I'm going to show you that if we calculated it with our previous equation, my value minus my mean divided by our standard deviation of 12, this gives me -1 divided by 12, gives me that z-score of -1. All right, so my calculator command, remember, lower boundary, here we're going to represent negative infinity by using -9 to the 99. Our upper boundary is going to be -1. Okay, with our empirical rule, we can kind of guess, right? So this was 13.5, 2.35, and 0.15, right? Which is about, does that give me 16% or so? Okay, so let's see if we get to be pretty close to that. Okay. So again, calculator command. I'm going to do second vars, normal CDF. Lower boundary here is we're going to use, say, negative infinity. Upper boundary is just -1. Keep that 0, 1, push enter. Look at that, about 0.1586. Okay, so the empirical rule actually rounds that up to 16%. Our empirical rule is really a generalization and it rounds. This one is actually more accurate to use the normal CDF. Okay, so we have a 0.1586 probability, or about 15%, 15.86% of the data is less than the z-score of -1. Or the probability of someone scoring less than 148 is 0.1586. Okay, let's do another one. Okay, so we're actually using the same bell curve as before with this. It wants to know someone scoring between 154 and 184. Okay, so the same bell curve as before, right? 154 will be here in the middle somewhere. And 184 is already on my curve. So we are looking in between these two. All right? I don't know the z-score of 154. It's not labeled for me. I'm going to have to find that. So 154 minus my mean of 160 divided by our standard deviation of 12. This will give me negative 0.5. And 184 is already on my bell curve, right? Remember that this is 0, 1, then the z-score here is 2. Calculator command, our lower boundary is going to be the z-score of negative 0.5, right? Lower boundary. Our upper boundary is a z-score of 2. Our mean, we're going to keep 0. Standard deviation, we're going to keep 1. Okay, so let's see what it's going to be in between. Okay, lower boundary is negative 0.5. Upper boundary is 2, 0. We'll keep those the same. There we go. We should get 0.6687. So probability of scoring in between those two, 0.6687, or a 66.87%. Okay. C takes it one step further. I'm actually asking you how many students would score a certain amount. So we're going to have to do the same steps we did before, and then we have one extra step to get the how many. Okay? So first things first, we're using the same bell curve. And you know what? We are going to change this number so it works better for us. Let's say how many is going to score 140 or less. Okay? So let's change that 100 to a 140. All right, so 140 is going to be about right here, right? So we have to find the z-score of that. So 140 minus our mean divided by our standard deviation. This will give me a z-score of negative 1.67. Okay. Probability of doing, okay, or less, so we're going to shade below. Okay. So remember, we're using z-scores here. So my lower boundary of z-scores, we're going to say negative infinity. Our upper boundary is going to be the z-score of negative 1.67. Our mean is 0. Standard deviation is going to stay 1. Use our calculator. We should get a probability of about 0.0478. Okay. So that's the probability of scoring 140 or lower. I want to know how many students, if 3,700 students actually took the test, how many of those are going to score 140 or less. So what we're going to do is we're going to take my probability of 0.0478 and we're going to multiply it by how many people took the test. So multiply it by 3,700. Okay? And that's going to give me approximately 176.87. Then remember, with people, we do always round up. Okay? So about 177 students. Okay? Would earn a score of 140 or less. Okay? So again, when I ask the how many question, you do the same thing you did before. Label your curve, find what you're looking for, convert that into a z-score, okay? Find your probability, then multiply that probability by how many students took the test or whatever. All right? All right, so this is the last one for notes today. I want you to pause this, all right, and try this one by yourself. And then play again, and then I'll go over the answer with you, okay? So go ahead and pause the video. All right, so here it is all worked out. Check your answers with mine, okay? What you should have done before anything else was take your mean of 75, put that in the middle, and then count both directions by a standard deviation of 4, okay? After we have this labeled, again, you don't have to do the z-score part. I just do it to help me out. It's asking me of scoring less than a 70, so I mark 70 on here and I shaded below it. I have to find the z-score of 70 because it's not on one of my labels, but I do know it should be in between -1 and -2, okay? So I take my value, which was 70, subtract my mean, which gives me -5, divide it by standard deviation of 4, which gives me -1.25, okay? I have to use my z-score in my calculator command for the normal CDF, okay? So I had to do -9 to the 99 because that represented, remember, our negative infinity all the way down here, okay? Up to -1.25. We kept our mean 0 and our standard deviation of 1 because remember, these are all z-scores, okay? Comes out to be a 0.1056 probability, or 10%, 10.5% people scored less than a 70, right? Part B wants to know how many of the 700 students that took the test scored less than a 70. So what we're going to do is use our probability that we just found, 0.1056, multiply it by the 700 students that took the test. I got 73.92. And remember, with people, we round up, okay? So about 74 students scored less than a 70 on our test. All right? So that is it for this lesson. What you are going to do now is you should have this worksheet, okay? You should have gotten it from the table when y'all walked in, okay? So first thing I'm going to ask you to do, fill in this using our empirical rule, okay? So z-scores go down here, and remember our 34%, remember all that goodness? So fill that out. 1 through 9 here, you're just doing z-scores. So 1 through 9 is just the practice of using the calculator command of the normal CDF. Remember, lower, upper, mean, and the standard deviation. These two is always 0 and always 1, okay? Let's see here. And then we get into the IQ tests. So if you took your IQ test over the weekend, you know what your score is. This is generally the scale of IQ scores and where you fall on the level of giftedness. So remember, our mean is 100, okay? So to be 115 or higher, you're considered to be gifted, some kind of form of gifted, okay? If you're not, if you're like right here, then you're just considered average. Nothing wrong with that, okay? So it's going to ask you here probability of being considered gifted, okay? So that means they want to know probability of being 115 or higher. That's what number 1 is asking you, okay? So find your z-score that matches 115 and find that and higher, okay? Then we come over here to our celebrities. So here we have Tom Cruise, Britney Spears, and the chick from Big Bang Theory, right? Dr. Amy Farrah Fowler. I found their IQ scores. I want you to find, it'll tell you higher or lower, okay, between those. And then on the back, we have Ashton Kutcher and Emma Watson, okay. For Ashton Kutcher, I want to know if it's more likely to have his IQ score or higher, or more likely to win the Georgia Fantasy 5 lottery, okay. So we have to see what the probability is of having an IQ of 160 or higher. And we'll see which one of these is better, okay? Which one's more likely, all right? The higher probability, the better. That means you're more likely to do that, all right? And there's Emma Watson, and then their final on the other side. We're using that same curve as the very front. Same thing with the IQ scores. I want to know probability that if I teach, where do I have it? Here we go. Below a 90. Okay, considered to be a high level of gifted. Remember, that's right here. So between 145 and 159. Probability of being exceptional, okay, above the exceptional. So that means 160 or higher. And then down here, 18, 19, 20, I'm asking you about how many students, okay? So you have to find the probabilities first and then multiply them by the 158. All right, I'll put an answer key to this worksheet up on eClass also, and y'all be good. Hopefully I see you soon.